Hi everyone, it's Scott from Maths Logos. In today's lesson, we're going to look at prime factorising using a calculator, and the calculator that I'm going to be using is the Casio FX991CW. So this is an A-level maths calculator if you're here in the UK, but you could also use a GCSE level calculator to do this. I'll leave a link in the description to a GCSE level calculator that you could use just to make you aware that's going to be an affiliate link. So let's look at our first example. Write 5,400 as a product of its prime factors. So what we want to do is we want to head over to our calculator, and I'm going to type in the number 5,400. And then if you're using a calculator similar to mine, you'll hit the execute button in the bottom right corner. Then we'll hit the format button, and we want to navigate down the list to where it says prime factor and click OK. And what your calculator will do for you is it will already prime factorize it. So let's just write out what the display gives us. It says 5,400 is equal to 2 cubed multiplied by 3 cubed multiplied by 5 squared. And what your calculator has done is it's rewritten 5,400 as a product of its prime factors. And just to give you a bit of a definition of what this means, in product of prime factors notation, which is what we see here, the number, in this case 5,400, is written as the multiplication of its prime factors. And we can see that we use powers to show repeated factors. So 2 cubed, 3 cubed, and 5 squared. What we could then do is use this prime factorized version to derive all of the factors of 5,400. So for example, I know that 2 is a factor, I know that 2 squared is a factor, and I know that 2 cubed is a factor, and so on. But I could also make up others. So I know that this number has 2 squared, and it also has 5 squared. Well, 2 squared is 4, and 5 squared is 25. 4 multiplied by 25 is 100. So I know 100 is a factor of 5,400. Now you would have known that already, but we can use the prime factorized version to derive all of our factors. Pause the video and give this question a go with your calculator, and I'll pop the answer up on screen in a second. So you should have came over to your calculator, you should have typed in 720, and then hit execute, format, and then converted it down to a prime factor here. And you should have got an answer as we see on screen there of 2 to the power of 4 multiplied by 3 squared multiplied by 5. The next type of example we want to look at is deciding whether numbers are prime or not using our calculator. And we want to have a quick think about what it would look like if the number was prime. So let's take an example that we already know is prime. If I know 3 is prime and I type that in my calculator and I hit execute and then I go to format and turn it into prime factor, if you notice, it just pops up exactly what it already was. It just pops up with the number 3. And to explain that, we need to understand what a prime number is. Well, a prime number is a number that has only 2 factors, 1 and the number itself. So when we ask our calculator to prime factorize 3, it's going to list all the prime factors. Well, we know 1 is not a prime number, so that's why the calculator just puts out the number 3, because 3 is the only prime factor of 3. So when we do these two questions, what we're looking for is, does my calculator just give me back the number that I put into it? In that case, it will be prime. But if it splits it into more prime factors other than itself, then we know that the number is not prime. So let's try each of these in turn. Let's try our 7,891. I'll type that in. Quite a large number, so it would be very hard for you to know if that's prime or not. And then we'll click execute and then format and down to prime factor. And what my calculator shows me is that 7,891 is equal to 13 multiplied by 607. Now what that means is both 13 and 607 are factors of 7,891, and therefore it's not a prime number because it has more factors than just 1 in itself. So I would say that's not prime. Let's look at the second example. So 223, put it into my calculator, and it gives me back 223. What that means is the only prime factor of 223 is 223. Therefore, that is a prime number. All right, pause the video and give these two a go. So 1,031, so you should have typed that in your calculator, and it gives you back itself, so therefore that's prime. Let's try 591, and we'll prime factorize it. And okay, we can see that we can write that as 3 multiplied by 197. So if I was listing out the factors of 591, I'd be saying 1 and 591 are factors. And if I just had that, then it would be prime. But I also know that 3 and 197 are factors. Therefore, it's not a prime number. Another thing we can do is we can use the prime factorized version of numbers to find their highest common factor. In this example, we have find the highest common factor of 140 and 448. Let's go ahead and actually see what they are as prime factorized versions. So we'll type in 140, execute format, and down to prime factor. And we see we can write 140 as being equal to 2 squared multiplied by 5 multiplied by 7. Let's do the same for 448. And I'll pop that into my calculator. And it gives me 2 to the power of 6 multiplied by 7. When it comes to the highest common factor of these two numbers, I want to look at all the factors that they have in common. So let's consider the 2's first. 140 has a 2 squared term and 448 has a 2 to the power of 6 term. Well, what do they both have in common? Well, they both have 2 squared in common. I'll then look at any other factors. So 140 has 5, but 448 does not have that prime factor. So I can't say that it's a common factor. And then I'll look at the 7's. They both have 1 7 in common. So I'll multiply that in as well. The highest common factor is 2 squared multiplied by 7, which I'm going to type in my calculator. So 2 squared multiplied by 7, which is 28. So that's the highest common factor. Pause the video and give this one a go. All right, let's go through this. So find the highest common factor of 90 and 585. Let's type 90 into our calculator and write it as its prime factorized version. So it comes out as 2 multiplied by 3 squared multiplied by 5. My 5's look like S's. Let's do the same for 585. Again, let's see what it gives us. So 585 is equal to 3 squared multiplied by 5 multiplied by 13. And same as before, we want to go through each of our prime factors and see what they have in common, and that will be our highest common factor. So they don't have any 2's in common. Of course, 90 does have a factor of 2, but 585 does not. So that's obviously not going to be a common factor. I'll then look at the 3's. So 90 has 3 squared and 585 also has 3 squared. So that would be in my highest common factor. I'll then look at the 5's. They both share 1 5 in common. I'll write that down. And they don't have any other numbers in common. So that's going to be my highest common factor. I'll type it in my calculator. So I'll do 3 squared. So the calculator has a squared button here. And then multiply that by 5. And that gives me 45 as the highest common factor. Okay, so on a similar note, we can use our calculator to find the lowest common multiple of 140 and 448. And obviously we wouldn't want to do this without a calculator because the lowest common multiple is going to be the number that's in both the 140 times tables, and you wouldn't want to really list those out for very long. And it's also going to be in the 448 times tables. Again, you're not going to want to list those out for very long. Now what you could do is you could use your calculator to list them out and find the multiple that is lowest to both lists. But what we can do is we can use our calculator to prime factorize instead. We had already prime factorized this number in the previous question. 140 was equal to 2 squared multiplied by 5 multiplied by 7, so I'll rewrite that. And 448 we had said previously was 2 to the power of 6 multiplied by 7. Now the way I like to do lowest common multiple questions is starting off by finding the highest common factor. And thankfully again we'd already done that in the previous question. And we'd find that it was 2 squared multiplied by 7, and we'd said that's 28, but I'm going to leave it in its prime factorized version for now. Then what we can do is we can say that the lowest common multiple is equal to the highest common factor multiplied by every single prime factor that's left over after we've accounted for our highest common factor. So what do I mean by that? Well, in our highest common factor here, we had already accounted for a 2 squared, so we wouldn't want to count that again in both lists. But in the 448, there would be a 2 to the power of 4 left over. So my lowest common multiple is my highest common factor multiplied by whatever would be left over. Well, there would be a 2 to the power of 4 left over after accounting for my 2 squared. Then we can look at our prime factor of 5 in the 140. That's not common to both lists, so that would of course be left over. So let's write that down. And then if you remember, in our highest common factor, we did use the prime factor of 7. So that's not left over. We've already used that up. My lowest common multiple is going to be my highest common factor multiplied by 2 to the power of 4 multiplied by 5. Well, I know my highest common factor was 2 squared multiplied by 7 multiplied by whatever's left over. We said 2 to the power of 4 and 5 were left over. And what I can do is I can write it in index form. I'll collect together my prime factors that are both 2. So 2 squared multiplied by 2 to the power of 4 is 2 to the power of 6. Multiplied by 5, multiplied by 7. Now I've got use of a calculator, so I can go ahead and type that in. So I'll type in 2 to the power of 6, To get the power of 6, I want to press this little button here, and that will allow me to type in 6, and then multiplied by 5, multiplied by 7. And that gives me an answer of 2,240. Pause the video and give this one a quick go. Okay, let's go through it. Let's start with our prime factorized versions of 90 and 585. And we can just use what we had in the previous question. So let me quickly write that down. Okay, so there we have our prime factorized versions of 90 and 585. And like I said before, if we want to find the lowest common multiple, I want to start by finding the highest common factor. I'll look at both lists and see what factors they have in common. They both do not share a factor of 2, but they both share a 3 squared. I'll write that down. And while I'm at it, I may as well score it out for later, because remember, we're going to use whatever's left over. Well, there's not going to be any 3s left over. I then look at the factors of 5, and they do share 1 in common, so I'll add that to my highest common factor. And then my lowest common multiple is my highest common factor multiplied by whatever is left over. Well, let's look at whatever was left over. Well, this factor of 2 is left over, so I'll add that in. And this factor of 13 is also left over, so let's add that in as well. The lowest common multiple is equal to my highest common factor. Well, remember I said that was 3 squared multiplied by 5, multiplied by everything that was left over that we didn't use in our highest common factor. To write it in index form, I'll start with the lowest prime number, which is 2, multiplied by 3 squared, multiplied by 5, multiplied by 13. So sometimes questions ask us to write it in index form, and you'd want to write that. But I have my calculator, so I can go ahead and type in 2 multiplied by 3 squared, multiplied by 5, multiplied by 13. And that gives me an answer of 1,170. So that would be the lowest common multiple. If you're using our lesson booklets, please complete exercises 1, 2, and 3, or alternatively, just finish watching the video and then complete all of your exercises after the video finishes. Okay, let's look at our next example. Show that 441 is a square number. Now, one way we could do this is to take the square root of 441. And if this gives us a whole number, then we know 441 is a square number. Let's go to our calculator and we'll use our square root button, which is this one, and we'll type in 441 and hit execute, and that gives us an answer of 21. Now what that means is 21 squared is equal to 441. Therefore, 441 is absolutely a square number. But let's also see how we could get there using this skill of prime factorizing that we've been working on today. So let's look at 441. I'll type that in my calculator and hit execute format and turn it into the prime factorized version. And that gives me 3 squared multiplied by 7 squared. Now what you want to notice there is that both of the indices on these numbers are multiples of 2. And if that's the case, then the number is a square number. We could also write this as 3 multiplied by 7 all squared. And remember, we could do this bracket. 3 multiplied by 7 is 21, so this is 21 squared. So 441 is 21 squared, therefore it's definitely a square number. So before you give this one a go, just have a quick think about what the indices would be if we're expecting it to be a cube number. Okay, let's go through this one. So show that 9,261 is a cube number. So again, like before, we could take the cube root of this number and type that into our calculator. Now how to do that, we need to hit Shift, go to our square root button and click that. Then instead of a 2, we're going to put a 3 up in the corner there and then type in our 9261. So this is going to do the cube root of 9,261 and it gives me an answer of 21. And what that means is that 21 cubed would be equal to 9,261. So 9,261 is 21 cubed, it's a cube number. But what we can do is also use prime factorizing to show that. Let's take our 9,261 and see what that would give me if I prime factorized it. And what it gives me is 3 cubed multiplied by 7 cubed. Now if you notice, because both of the indices are multiples of 3, then it's going to be a cube number. If just one of the indices was a multiple of 3 and the other was not, then it wouldn't be a cube number. And like before, another way that we can write this is as 3 multiplied by 7 all cubed. And we'll do our bracket. 3 multiplied by 7 is 21. So we've shown that 9,261 is 21 cubed. Now the reason I'm showing you this is because the next question uses this idea quite heavily. So let's apply what we've learned in the previous example to this question. What is the smallest number that 540 must be multiplied by to make a cube number? Now remember, we know what we should expect when we're looking at a cube number. All of the prime factors must be raised to a multiple of 3. So let's see what 540 is as it currently stands, and then we can make a decision what we need to do to turn it into a cube number. So let's type in 540, and we'll look at the prime factorized version of that. And it's 2 squared. So already we're seeing that it can't be a cube number because this is not a multiple of 3. Multiplied by 3 cubed. So that's okay. We've got a multiple of 3 on the index there. Multiplied by 5. And that's not okay. We need a multiple of 3. So in order to turn 540 into a cube number, I'm going to need a 2 cubed here. Well, how would I do that? If I currently have 2 squared, if I multiplied it by 2, well, that would give me 2 cubed. So I know I'm going to need to multiply by 2. The 3 cubed is okay, I can leave that as it is. It's already a multiple of 3 on the index, but the 5 I need to do something with. Well, if I see what 5's like already, we could think of that as 5 to the power of 1. I would need to multiply by 5 squared in order for it to be a multiple of 3 on the index. So I need to multiply by 5 squared. And what I can see is I'd need to multiply by 2 and I'd need to multiply by 5 squared. And if I did that, the number that I would get is 2 cubed multiplied by 3 cubed multiplied by 5 cubed. And that would definitely be a cube number. But let's make sure we've answered the question. What is the smallest number that 540 must be multiplied by to make a cube number? Well, that number is going to be 2 multiplied by 5 squared. Because remember, I needed to multiply by both of those. And let's type that in our calculator. So that's 2 multiplied by 25. So that's 50. That would be my answer. Okay, pause the video and give this one a go. Let's run through it. What is the smallest number that 90 must be multiplied by to make a square number? Let's take 90. And what we'll do is we'll find the prime factorized version of that. We'll see that that gives us 2 multiplied by 3 squared multiplied by 5. Now this time I want my end result to be a square number, and for that we're looking at our indices to be multiples of 2. Let's look at our prime factor 2 first. The index here is currently 1, and if I think what would I need to do to 2 to the power of 1 to make it to 2 to the power of multiple of 2? Well, if I multiply it by 2, that would give me 2 squared. I need to multiply by 2. The 3 squared is okay as it is because it's already got an index that's a multiple of 2. The prime factor of 5 is currently 5 to the power of 1, and I would need to multiply 5 to the power of 1 by 5 to make it 5 squared, and that would then be a square number. So I need to multiply this number by 5 as well. So if I need to multiply 90 by 2 and then by 5 to make it a square number, well, what is 2 multiplied by 5? Well, I need to multiply by 10. What that means is that 90 multiplied by 10 should be a square number. So let's see what that does. 90 multiplied by 10 is 900. And I should be able to take the square root of 900 and it should give me a whole number answer. So I'll do the square root of 900 and that gives me 30. So I know that 900 is definitely a square number. If you're using our lesson booklets, you can now complete exercises 4 and 5. Thank you very much for watching this video.